Hey everyone, and welcome to this new video in the series for coordinate geometry. And in this video we will be talking about conic sections. In the previous videos we talked about the basic concepts in coordinate geometry, and then we went towards lines and angles. In this we will start with the conic sections. So conic sections basically revolve around these four different types of structures, or if you can say four different types of sections. What conic section basically made up of is that if you have two cones, this cone over here, if you put a cone which is resting on its base, and you put another cone on top of it, and you have a vertex over here, the top of one cone touches the top of the other cone, then you have two cones with each other, one on the top, one on the bottom. If you cut these two cones into four different shapes, you will get four conic sections. Those conic sections are the parabola, the hyperbola, the ellipse, and the circle. So if you cut the conic section over here, you will get a parabola, and if you cut the cone over here, you will get the hyperbola, and then you have the circle, and then you have the ellipse, which, well, if you look at it, would look like a slanted circle, but we'll get to it how that is made. So if you want to have a closer look of how the conic sections are made, you can look over here. Let's just say you have like a sheet of glass or something, and you have this two cones made up of wax. If you want to make a parabola out of it, this is what you do. This is the direction that you cut in. If you take the sheet of cutting piece or whatever metal or glass that you have, if you cut it in this direction, you're gonna get a parabola, as we saw over here. This shape over here is known as a parabola, and just like that, you have the hyperbola. If you cut it over here, like in a vertical direction, you're going to get a hyperbola that you see over here. This shape over here is going to make an hyperbola. Of course, you all know what a circle is, and in order to cut out an ellipse, we need to slant it a certain angle, and then we can get an ellipse out of it. So let's start talking about these conic sections in a little more detail. Let's start with the most basic one that we see all around us, that you guys have already studied, and that is the most basic one, and that we can relate to, and that is a circle. So circle, as like I told you, we can see all around us in man-made structures and in nature as well. There are many circles that you will be seeing in your room, maybe the top of a cup, or many other things that you might have, many utensils or many other things that you might have in your room. So this is the basic equation of a circle. This is known as a standard form of a circle, which is centered at 0, 0. By 0, 0, I mean on a graph and the coordinate on the x and y axis. 0 and 0 basically means 0 on the x-axis and 0 on the y-axis. So the circle would basically be an x squared. The equation for the circle would be x squared plus y squared is equal to r squared. What that means is that you take the distance. R over here is the distance of the circle from the origin. So this would show you over here that if this is the origin over here, so this length over here would be 2, and this length over here would be 2 as well. We know what the radius is, so r over here would be 2. That will be the radius. If you look at it closely, if you want to like find out what x and y is, let's take a value of x and y. Let's take this value of x and y over here. So x over here is basically 2, and y over here is 0. So if you put these values in this equation, so it's going to be 2 squared plus 0 squared, and the answer is going to be r squared is equal to 4, and that will give you the answer r is equal to 2, which we already discussed before, that is the answer to this equation, that is the radius of this circle. So the x coordinate, these x and y's are basically all the values on the line of the circle and inside the circle, basically any value of the circle that's going to give you an answer, and that is r squared for any circle that is centered at the origin, that is centered at 0, 0. Moving on, what if the circle is not centered at 0, 0? What would the equation then? The equation then would be a slight offset from x and y. So you see over here, now this circle is basically centered at 3, 3. So that is what it's going to be. So this is the new equation for a circle which does not basically is not centered at 0, 0. If you look closely at this equation over here, you would see that basically this is the standard form equation. we're just putting in the values, different values over here. If you look in the previous diagram, you would see that it is centered at 0, 0. Now h and y are just the new forms of the x and y coordinates that we have for the center of the circle. H and k over here would be 3, 3. In the previous example, h and k would be 0, 0. So that is why if we substitute 0 and 0 over here, and 0 over here and 0 over here, we're just going to get the same equation over there. You're just going to get x squared plus y squared is equal to r squared. So if you really want to learn an equation, then learn this equation, so that you would know that what the center of the circle, the role the center of the circle plays in the standard form of the circle, the role the center of the circle has in the equation of the circle. So x minus h plus y minus k would basically represent the offset of the circle with respect to the origin. So you don't have to remember that, but what you need to remember is that h and comma k is the center of the circle. You substitute those values over here, and then you get a new equation over here. So this equation over here is going to become x minus 3 whole square plus y minus 3 whole square is equals to 4, because we know that the r is equals to 2, so r square is going to be 4. This way we know that the center of the circle is 3, center of the circle is 3, 3. We just put in these values to solve for any coordinates for x and y. And also for if you want to find the radius of the circle, we substitute the values of any x and y in there, and we get the radius of the circle. So this is pretty much it for circles. It's not a complex topic. I just wanted to get this equation through to you. Remember that this is the equation that you see on the screen right now. This is the main equation for a circle, and x and y are any coordinates on the circle, the x and y coordinates, and r is the radius. H and k is the center of the circle. Now moving on with the next conic section that we wanted to discuss, that is a parabola. Now just like circle, parabolas are also around you, but we seldom notice them because we are more accustomed to circles, and they're like not that straightforward to look at, to understand, comprehend. So if you look at the parabola over here, you can see these parabolas all around you as well. This is the Golden Gate Bridge in San Francisco in California in USA, and you can see I'm pretty sure that all of you have already seen this image or this situation in your life as well. So what is a parabola? Now let's first discuss the definition of it. Parabola is a set of all points in a plane such that each point in the set is equidistant from the line called the directrix and the fixed point called the focus. Now this F represents the focus, and this line is called the directrix. We basically use this line, the directrix, so that with that we can help understand the conic section. And we have an F, which is a point inside the it could be inside, but right now you see there is no ending to this parabola, so the concept of inside and outside does not exist over here. So we made a directrix over here. We could have drawn it over here as well, or over here, or over here. We could have drawn the directrix, this line that we use to help us understand the parabola. We use this line over here, and then we use an F over here. Now if there is a point on this parabola which has equal distance to this F over here, and which has an equal distance to the directrix over here, then we will call this point a parabola. These points that you see over here are going to be known as a parabola. Of course you can see it with the help of just the shape, but it's good to know the technical definition of it. So all those points which have any two other points, that is one point or any two other distances, one leading to the directrix and the other one leading to a particular point, if the distance between these two is equal, then we have a parabola. Then we will call that set of points which are with each other, like these points over here, then we'll call these set of points as a parabola. Now moving on to the equation of a parabola. Now the standard form, we already discussed the standard form for the circle. Now this diagram over here shows the standard form for a parabola. Now if you have a parabola like this, which is centered at 0, 0, we'll start with the basic one. So if we have a parabola like this which is centered at 0, 0, this is going to be the equation of it. Now I'll get to the values, what these particular values mean, what does y mean, what does p mean, what does x mean, and what is 4. I will get to that. So right now just concentrate on this, that this is the center of the parabola. You have this is basically what you can call as it cuts the parabola into two halves. So this parabola is represented by this equation, y squared is equal to 4px. So moving on, what does this 4px mean? So first of all, you need to know that since this parabola opens up to the right, we'll have a positive parabola. We'll have a positive value over here, that is a positive 4. There, of course, there are parabolas which are going to open to the left, like this one over here, or negative 4 over here. But of course, I will explain to you why this happens and when it happens. But right now, let's concentrate on this. So since it opens to the right, we have 4. We have a positive. P is the distance that we talked about. This distance over here is known as P. This distance that we're calling over here is known as P. So this P over here is the distance that has to be equal for a particular point to the F focus point and to the directrix. So if that is the case, if the P is the value of that point, so the coordinates of the focus are going to be P comma 0. What does that mean? That basically means that it is somewhere on the x-axis. So if it is p comma 0 for the focus, it has to be equidistant for the directrix. Now the vertex over here is this. Vertex is any point where 2 points meet. So this y-axis over here, x-axis over here, and this curve over here meets it. So this is the vertex. So P is going to be the distance of the focus from this over here to the vertex, which is sent because the parabola is centered at the vertex. So this is going to be the equation for that. This is going to be the distance for that focus. And since, like I said, it has to be for the same distance from the directrix, it will be P length on the opposite direction to the directrix over here. So that tells us two things. First of all, that the P for the directrix is over here, and secondly, the directrix is somewhere over here, and it is a vertical line. That is what is written over here as well. That since the focus is P comma 0, the directrix will be x equals to negative P comma 0, right? So that is going to be the directrix, and that shows that the axis of symmetry is going to be y is equal to 0. Now what does y is equal to 0 mean? Y is equal to 0 is basically this line, the x-axis. The x-axis shows us that y is equal to 0. The x-axis, why is that, and how is that important to us? That is important to us because it is the axis of symmetry. It splits the parabola into two equal parts. So this is the line over here, that is y is equal to 0. It splits the parabola into 2. So y and x, we know that these are the coordinates. It is a positive value because it opens to the right. It is P that is the distance of the focus and the directrix to the vertex, that is to any point on the parabola. Okay, now moving on. This is the standard form for any parabola that's going to open to the left. If you look over here, you're going to see that this parabola over here has a value of negative 4px. Why does it have a value of negative 4px? It has a value of negative 4px because it opens to the left. Now if you look at over here, look at this graph, let's decipher this graph. So this is the directrix that we have drawn over here. We know that this is 1, right? The vertex is 0 comma 0. So we know that this distance is 1. So the distance of the vertex to the directrix is 1. So that way we know that directrix is x equals to 1. So we also know that the focus is going to be the equal direction, the opposite direction, because the focus has to be the equal direction to the vertex, right? So if you look at over there, that you are going to see that the focus is going to be negative 1 comma 0. It is a point and directrix is a line. So that is why it has two coordinates and it only has one coordinate. And you can of course you can shift it over here, and you can substitute 1 over here because that is the value of P, and then you can take it to the other side and make it a positive equation like this. So just like the previous example that we read and that we saw, it is the same one. The only difference is that it has a negative 4, and the reason for the negative 4 is because it opens to the left. I want to tell you something over here, that this is the equation for the parabola that is centered on the x-axis. That the x-axis, then when y is equal to 0 is the axis of symmetry. This will be the equation of the parabola. The value of the numerical over here is going to be 4. This is a rule. It is going to be 4, and then you're going to have p, which is the distance, and you can have two values y and x. There's no change in that. It is always going to be 4. So the only thing that you have to remember is, even if it is centered along the y-axis, it is still going to be 4. Right now it is centered along the x-axis, it is 4, and even if it is centered along the y-axis, it's still going to be 4. So if you look over here, all you have to do is you have to know one thing, that you need to find out the directrix, and that you need to find out the value of p. Then you can start solving this. Of course, make sure that you recall that if it opens to the right, it is positive 4. If it opens to the left, it is negative 4. So that is the thing that you have to realize. And this is the end of this video. We only talked about the circle and the parabolas, the basic equation of a circle, and we talked about if it is not centered on the origin. We talked about what a parabola is, and the parabola that is centered on the origin, and which opens to the right and which opens to the left. How that the only difference is the sign. We talked about what a focus is and what the directrix is. In the next lecture we'll be talking about the parabolas which is centered on the origin, but the axis of symmetry is the y-axis rather than the x-axis. So the axis of symmetry will be x is equal to 0 rather than y is equal to 0. We'll be continuing with this in the next lecture. Thank you very much.